So you are welcome to Geometrium online class. So we want to talk on this topic: symbol, formula, and equation. The plural of formula is formulae. So you can see the board clearly. We start with chemical symbols. How do you recognize chemical symbol, and how do you write chemical symbol in the way that is acceptable? Now, we are going to take them in batch. The first batch is element with first letter of their names as symbol. So we have the atomic number, the element, and the symbol. So atomic number 1, that is, the element is hydrogen and having capital letter H. So we have number 5, boron, B, 6, carbon, C, 7, nitrogen, N, 8, oxygen, O, fluorine, number 9. Now, I'm going to dwell on that. This is what happened. Some students, we want to write this fluorine, they will write it this way. Fluorine. They will say the symbol is this is wrong. We don't accept this. It should be straight stroke. Straight strokes, not curved stroke. So straight stroke and not curved stroke. This, I think you get that. So that is the way fluorine should be written. Capital letter F. Then phosphorus, number 15. Phosphorus, number 15. And we have sulfur, number 16. Vanadium, capital letter V, number 23. So now, so the tritium, that is the one with capital letter Y, that is atomic number 39. Iodine, number 53, capital letter I. And number 92, uranium, capital letter U. So we want to go to the second batch now. That is element with first and one other letter of their name as symbols. We have number 2, helium, He. That is, the first letter should be capital letter, while the second letter should be a small letter. So we have number 3, lithium, Li, number 4, beryllium, Be, number 10, neon, Ne, number 12, magnesium, Mg, number 13, aluminium, Al. So let me pause the video there and explain something. Aluminium, it is not written this way. This is not acceptable. It should be A, then L. This should be a curved stroke, not straight stroke. So it should be curved. So Al. That is how to write aluminium. Now the next one, silicon, Si, chlorine. The same thing goes to chlorine. Chlorine is C, then curved stroke, not like this. If you write it like this, you are wrong. So this is the acceptable way to write it. Now we have argon, calcium, and scandium. I think we can now go to the next one. Continuation of that. Number 24, we have chromium. Number 25, manganese. Chromium is Cr, manganese is Mn. Zinc, Zn, that's number 30. Number 32, arsenic, As. 35, bromine, Br. 36, krypton, Kr. 37, rubidium, that's Rb. 38, strontium, that's Sr. Number 48, cadmium, that's Cd. Number 55, cesium, that's Cs. 56, barium, that's Ba. Number 64, gadolinium, that is Gd. Number 65, terbium, that is Tb. And number 73, tantalum, that's Ta. Number 86, radon, that is, you always call it radon. Radon. So it should be radon. The radon, that's Rn. And number 89, actinium. Actinium is. So these are elements. These are elements and the atomic number with symbol. That's the proper way to write it. So I think you can move forward from there and look at the last batch. Okay, as we continue, the third part is elements that derive symbols from their Latin names. Let's see those elements. Element with atomic number 11, that's sodium. Natrium, that is Na. So the Latin name is natrium, that's where they got the symbol from. So those Latin names gave us their unique symbol. Now we have copper. Okay, iron is ferrum, that's Fe. Copper is cuprum, that's Cu. Silver is argentum, that's Hg. Silver is Ag, that's argentum. We have tin, sternum, Sn. We have number 51, antimony, that is the stibbium, that is Sb. And number 74, the tungsten, that is the wolfram, is W. So gold is Urum, that is Au. And number 8 is mercury. Mercury is hydrargyrum, that is Hg. And while lead, which you always call lead is plumbum, which is Pb. So from there we go to chemical formulae. So we have chemical formulae. The formula A for compound containing the symbols of different elements that combine chemically to form the compound, that is composition of the compound. So a molecule of an element is represented by writing the symbol of the element to the right. If it is a molecule, so you write the symbol to the right, not to the left. That is, when we have hydrogen gas, which is a molecule, it is written as H2, oxygen gas O2, nitrogen gas N2, chlorine gas Cl2, ozone O3, P4, and sulfur S8. So those are the molecules of those elements respectively. So from there we are going to some compound and their formulae. So we can see that on the screen. We have different compound with their formula. Sodium oxide. We are still going to do, we're going to show you how we came about joining these elements together to give us the formula. So sodium oxide is having Na2, carbon dioxide is having CO2, hydrogen sulfide is having H2S, iron 2 oxide is having FeO, zinc sulfide is having ZNS, lead 2 chloride is having PbCl2, nitrogen 5 oxide is having NO2, and potassium chloride is having KCl. Now, before we come back to how we came about those compound that we just said now, let's talk about radicals. So what are radicals? Radicals are a group of atoms carrying charges. So, and they exist as simple unit. So can you see on the screen radicals? Radicals radicals they are groups of atoms carrying charges and exist as a simple unit. So you call something a radical when it has more than one. See, this is a radical because it is having oxygen and manganese with a common charge. So that's why we call them radical. They are group of atoms. So you call them radicals. So if it is just one, you don't call one radical. You either call it aeon. Aeon in what form? Whether it is a cation or an anion. But it's a radical when they are coming together with a common charge. That is the name we call it radical. Now, let's see examples of this radical. We have tetraoxomanganate 7. It is called aeon. Why? Because there is a charge, collective charge on top. That is why aeon should be pronounced last. I will still teach you how to pronounce compound, how compound should be pronounced in chemistry. So, but what we want to do now is that I want to recognize those radicals, their oxidation number, and their valency. Because we need this valency to form our compound, those molecules that we need to talk about later on. Now we have second one, triazonitrate 5, and I will tell you how to get this number written in Roman numeral form. So this is tri. Anytime you see a radical and with a common charge, the last by the left, we have its name ending with 8. So nitrogen, we have 3. 3 means tri. 3 means tri. So the oxygen will be pronounced as oxo. While the one by the left, we have its name ending with 8. ATE. So nitrogen will become nitrate. Nitrogen will become nitrate. So we're going to talk about the way we get the number later. So this is trioxonitrate 5, and it is called aeon because of the charge on top. This is oxo, manganese changed to manganate. So this is trioxo, chlorine changed to chlorate. You understand? Chlorine changed to chlorate. Then I will tell you how they got 5. But before we get there, anywhere you see MnO4 minus, please, this is the name. It will not change. That's the name. Do you understand? So you get used to it before we even analyze it to get the number, the oxidation state. Now we have trioxochlorate 5. We have hydroxide ion OH. We have tetraoxosulfate 6 SO4. That is a popular radical. We have triazocarbonate 4. We have tetraoxophosphate 5 PO4, and we have ammonium ion NH4. Please take note of something. There's something I want to explain to you guys. Oxidation number, you can see that it is having a sign, a positive sign for this one and a negative sign for the rest. Why? Because the number here on top is called the oxidation number.
That's the oxidation state of that particular radical. You understand? Now, the valency is that same number but without that sign. That is the valency. Please understand what is valency. Valency is that number without the sign. Do you understand? So it is the valency we now use to get the compound. That is the proper compound that thing should form when it is combined. You understand? So that is what I want you to get now. So later we go on and show you how they get compound in chemistry.